All right, I'm gonna try this again. Sorry the video's late today. I just got done recording the whole video, and then it turns out my internet messed up and it didn't save any of it. So now I've got to redo the whole video. Um, so let me go back through this again. And anyway, so here we go. Go get some paper, get something to write with, so that you can take your notes. This chapter we're starting functions, and it's a lot of easy things, but it's a lot of things. It's a lot of different things to remember. So it's important to use your notes to write everything down, so that it will make things easier for you in the long run. So get something to write with, get some paper to write on. Um, and make sure you're paying attention to the things I ask you to write down. So first off, this would be the bell ringer we would do in class. Um, the main thing for this is that this is some prior knowledge that you've got to know to do this topic. And that's that if you look at a set of points, you've got to be able to tell which ones are the x values and the y values. That's going to be very important when it comes to functions. If you can't look at this and tell me which numbers are the x's and which numbers are the y's, there's no way you can do any of these problems. So if we take a look, which ones are the x values? Remember, the x values are the numbers in the front of each point. So our x values would be 2, -1, 7, and 0. Our y values are the numbers in the back of a point. So our y values would be 5, 8, 4, and 9. So you've got to be able to do that in order to answer the questions in this chapter. So let's take a look. Our learning goal: I can decide if a relation is a function and use function notation. So the main thing we're going to talk about today is what is a relation, and then how to tell if it's a function. So what is a function? All right, so before we can do anything, we got to figure out, well, what is a relation? I can decide if a relation is a function. Well, that's great, but I need to know what a relation is and then what a function is. So if we look, we have set A, and it's just a set of points. So we've got these 5 points, just a list of points. A relation is a set of ordered pairs. So that's what a relation is. A relation is when you just have a set of points. So I've got these 5 points, that's a relation. So remember, the learning goal is that I can tell if a relation is a function. Well, now we know what a relation is. A relation is just a set of points. All right. And then you've got to be able to list what is the domain and what is the range of a function, or of a set of a relation, of a set of points. So if I look, the domain is just a list of the x values. So if I look at all these points, just like we just did on the bell ringer, labeled the x's, labeled the y's, that's the same thing for domain. Domain is what are the x values. So if we go through, what are our x's? We have 0, 1, 1, 4, and 4. And if you notice, you only write them one time. So you wouldn't put 0, 1, 1, 4, 4. If I have 2 positive ones, I only need to list it one time. All right, so the domain is the x values, and this is going to come and be important here in a little bit when we talk about mapping later on in the notes. You'll have to find the domain and range and use that to make the mapping diagram. So you got to know domain is the x values, where none of them repeat. You just write them one time. So then the range is the y values. So we have 0, +1, -1, +2, -2. All right, so that's the range. And if you notice, they put the range in order from least to greatest. So you got to make sure you always, when you label the domain and the range, you always put them in order from least to greatest. The x values were already in order, so we didn't have to worry about that. So what's the domain? It's our x values. What's our range? It's our y values. I would definitely pause the video, write this slide down so you have this, because you're going to have to answer questions on what's the domain and range. So make sure you understand what that means. All right, so moving on to our next thing, we have a set of tables. What is a function? A function is a relation. So remember, a relation is a set of points. So a function is a set of points where every x has one and only one y. So that means when you go through the list of points, whatever your x values are, they only go to one y. So if x is 5, 5 only goes to 2. 5 couldn't go and match with 0.52 and 0.57. That would mean it's not a function. So to be a function, and this will make sense once we do some examples, each x can go to only one y. So if we look at the table to state whether the relations are a function, all we're going to do is go down the x side of the table and see if anything repeats. Because if it repeats, then that means you have an x going to two different numbers, and we can't have that. So if we look, we have positive 4 matches with the 2. Are there any other positive 4s? Nope. So we're good. All right. Negative 3 matches with positive 8. Any other negative 3s over here? Nope. So we're good. Positive 6 goes with positive 1. No other 6s. Negative 1 goes with positive 9. No other negative 1s. 5 goes to positive 6. No other 5s. So each x only goes to one number. So that means that it is a function. Each x goes to only one y. All right. Now, that'll make sense once we see an example that's not 1. So if we look at the middle table, 1 goes to 3. Any other 1s? Oh, yep. 1 also goes to 4. So can we have an x going to two different y's? Can we have 1 going to 3 and 1 going to 4? No, we can't. Not allowed. If you see that, then it's automatically not a function. You cannot have an x going to two different numbers, which means the shortcut to answering the question would be to just look at the x side and see, do you have any numbers repeating? If it's repeating, if you have the same number more than once, then you know it's not a function. Oh, I've got a positive 1 and another positive 1. Not a function. 1 cannot go to 3 and to 4. It is not allowed in order to be a function. All right, let's look at this table. 2 goes to 3. 5 goes to 7. 3 matches 8. Negative 2 matches with negative 5. 8 matches to 7. Are any of the x's on here more than once? Nope. So it is a function. Now, some students would look at this and they would say, but I have a 7 and a 7. Doesn't matter. You don't even need to look at the y values. They don't matter. All that matters is that when you look at the x's, each x is only on there one time. All right. So you look at these three and you tell whether they are functions or not. So pause the video, look at these. You can write it down if you want some examples, or you can just look at them and decide what you think, functions or not of functions. So hopefully, to make sure you know what you're doing, you paused the video and you did the questions and you looked at them and you decided what you thought the answer was. So let's take a look. What did you think for the first one? Function or not a function? It is a function. Why? Because if you look at the x's, do any of them repeat? 0, 5, negative 2, 4, 3. Nope, none of them repeat. You don't have any of the number more than once, so it is a function. All right, look at the middle table. Positive 2, negative 2, negative 4, positive 3, negative 3. It is a function. Why? None of these repeat. Doesn't matter that I got 2 4s here. Nobody cares. Y's don't matter. The x's are all that matters. All the x's are different, so it's a function. And then if you look at the last one, what'd you put? You should have put, or you should have thought that it was not a function. Why? Because look, I have a 1 and a 1. Can't have that. I also have a 4 and a 4. So you can't have 1 go into positive 1 and negative 1. It's not allowed. So not a function. Okay? So we've gone over how to tell if a table is a function or not. So now we're going to talk about how to tell if a set of points is a function or not. And the good thing with this is that when you're looking at it, you do it the same exact way as telling if the table is a function or not. All you have to do is look at the points and see, do any of the x's go to more than one y? So if I look, same thing, ignore the y's, just look at the x coordinates, just look at the numbers in the front. I have a 0, a 1, a 2, a 3, a 4, and a 5. So do I have any of the same number more than once? Nope. So since I don't have any of the x's more than once, yes, it is a function. So if I would have said 0, 1, 2, 2, 4, 5, then it would be no, because I would have said 2 twice. But since all of the x's are different, that means it's a function. So what about this one? Function or not a function? You take a look at it, you decide. All right, pause the video if you need to. You decide function or not a function. And now let's look. What are our x coordinates? -1, +1, +2, 0, 0, -2. So did I have any of the same number more than once? Yeah, I had 0. I have a 0 going to a -8 and a 0 matched with a 5. You cannot have an x going to two different y's. So since I have a 0 and another 0, no, it's not a function. All right, so that's how you tell if a set of points is a function. All right, same way as a table. Just look at the x's and see, do you have the same number more than once? If you do, then it's not a function. If all the x's are different, then it's a function. Now, we've talked about two different ways to look at relations. You can have a set of points, you can have a table, and now you're going to learn a new way to list points. It's called mapping. It's a new way to do it, something you haven't looked at before, you haven't done it before. It's kind of like a table, but instead of setting it up with boxes in the table, it's two ovals. You have your input and your output. So your input is your x, your output's your y. Basically what you're going to do is you'll put an oval, and I know this isn't an oval, but when you write it on your paper, connect this and make it into an oval. So you've got an oval on one side, an oval on the other, and basically for the input, all you do is write the domain. So this is where you got to remember, what's the domain? What's domain mean? It's all the x values. So if I look at the x values, what is the domain? I've got -2, -1, 0, 1, and 2. So -2, -1, 0, 1, and 2. You just put the domain there. And remember, domain, if you have the same number repeating, then you have to only write it one time. So if this would have been -2, -1, 0, 0, 2, then we still would have only put 1, 0. You wouldn't put 0, 0. And you'll see some examples of that in a minute. So now you put, okay, what does each number go to? What's it match with? So what's -2 matched with? It's matched with -4. So you're going to draw an arrow over to here. You're going to put -4 on this side, and then you draw an arrow, and all you're doing is showing what the numbers match to. So -2 is matched to -4. So you just put the -4 on this side, draw an arrow connecting them. What's the -1 go to? -1 goes to -2. So we're going to put a -2, draw an arrow showing that -1 goes to -2. All right, what's 0 go to? 0 goes to 0. So 0, draw an arrow connecting them. What's 1 go to? 1 goes to +2. So put the +2, draw an arrow connecting them. And then what does 2 go to? 2 matches with 4. So put a 4, draw an arrow connecting them. That's it. That's what mapping is. Mapping basically shows your domain, shows your range, and it tells you x goes to what y. -2 matches to -4. 0 goes to 0. 1 goes to 2. And then you got to tell, is it a function or not? Remember, what's the definition of a function? Every x can only have one y. So if I look, each x can only have one arrow leaving it. If there's only one arrow, it's good. So only one arrow, good. Only one arrow, good. Only one arrow leaving the 0, good. Only one arrow leaving the 1, good. So then it is a function. Okay, and that'll make more sense when we see some more examples. So let's look at the next page, look at some more examples of mapping. So if I have these two, so if I have this mapping, 1 goes to 6 and 1 goes to 7. 2 goes to 7. So is it a function? Well, remember, what's a function? Every x can only go to one y. So is this one a function? No. Why not? Well, the 1 is going to a 6 and a 7. Can't do that. All right. So if you notice that that one number has 2 arrows leaving it, then it's not a function. Now, the fact that 1 and 2 both go to 7, that's fine. That doesn't matter. Remember, the y side doesn't matter. All you do is look at the x side and see, okay, 2 arrows, so not a function. Only 1 arrow, so that's fine, but you got 2 right here, so not a function. So what about on this one? 1 goes to 6, 2 goes to 6. Function. That's fine. They can go to the same number. You just can't have 2 arrows leaving the same number. 1 only goes to 6. 2 only goes to 6. That's fine. All right. So let's look at some more. Let me pull this up here. So we got that table. Input, output. So what's the domain? -2, -1, 0, 1, and 2. So -2, -1, 0, 1, and 2. What's the output? We have 0. So we have 2, 1, 0, 1, and 2. So the output is the range. The range is what are our y values and put them in order least to greatest. So we've got what? 2, 1, 0, 1, 2. So what's the smallest number? 0. So we put 0. What's the next one? 1. Oh, I got 2 ones. Do I write 2 ones over here? No. I just put it one time. And then I have what? 2 and 2. So I just put it one time. So that's something you got to be careful of. You're not going to put 2, 1, 0, 1, 2. You've got to just put the numbers one time and put them in order least to greatest. All right. So now we need to draw our arrows. So -2 goes to what? It goes to 2. So from -2, I'm going to draw an arrow going where? All the way down to 2. Okay, does that make sense? So first thing, we write our domain on this side. We write our range on this side. And then we draw arrows showing what each number goes to. So what's -1 go to? +1. What's 0 go to? 0. What's 1 go to? +1. What's 2 go to? +2. And then you got to check to see if it's a function. So if we go down, does any of the numbers over here have 2 arrows leaving it? Does any of them have more than 1 arrow? Well, let's see. -2 only has 1 arrow, so that's good. -1 only has 1 arrow, so that's good. 0 only has 1 arrow, so that's good. 1 has 1 arrow, 2 has 1 arrow. So that is a function because each x only has 1 arrow. Each x is only going to one y. So if we come and look at this one, what would our mapping look like? Go ahead and pause the video. You draw the mapping, draw your arrows, and you decide if it's a function or not. All right. So you should have paused the video, done that. If you did, hopefully we'll see. So what is our input? What is our domain? We have 2, 1, 0, 1, 2. So put them in order least to greatest. And if you have any duplicates, only write it one time. So that would be 0, 1, 2. All right, same thing for your y, your output, your range. So what is our range? What's the smallest number? -2, -1, 0, 1, 2. So now let's draw our arrows. All right, first we have 2 goes to -2. Okay, so they're going to go down the order. Okay, so the first one's 0. What does 0 go to? 0 goes to 0. So we draw that. Then we have 1. What does 1 go to? 1 goes to -1, and 1 also goes to +1. All right, and then we have 2. 2 goes to -2. 2 also goes to +2. So is it a function? Well, let's look. 0 only has 1 arrow, so it's good. Oh, but 1 has 2 arrows, so that's a problem. Can't have that. 2 also has 2 arrows. Can't have that. So not a function. All right, so that's how you tell if mapping is a function or not. So let's look at these two. Which mapping represents a function? Choice 1 or 2. So pause the video, look at it, you decide which one is a function, which one is not a function. So which one is a function? Choice 1. Choice 1 is a function. Why is it a function? Because there's only 1 arrow leaving each one. If you look at choice 2, -1 has 2 arrows, can't have that, so not a function. So choice 1 was the function. All right, what about these? Which one is a function? You should have B. B is the function, this one. 2 is going to 3 different things. 2 has 3 arrows. You can't have that. Not a function. A only has 1 arrow. B only has 1 arrow. C only has 1 arrow. So it is a function. All right. All right, and that's it. That's going to be it for the notes for today. The function notes are actually, instead of making one real long video, I'm doing 2 separate videos. So you'll have a video today over the intro, the first half of functions. And then the next class period, if it's online, then we'll have the second half video for you to watch. If it's in-person class, then I'll go through the second half in person with you. All right. So all you have to do for today is watch this video. Sorry, I'm posting it late. Had the internet problems, but you don't have any work to do today. All you got to do is watch this video and then comment on the post that you watched it so I can give you points for today for watching it. If you have any questions, just email me and let me know. All right. Go ahead and exit off of this.